So if life had ever developed here at all, it would be living in pineapples under the sea. But by the same principle, if Earth had been a little smaller, wouldn't have held on to any of its water. Scientists believe that's what happened to Mars, which is just over half Earth's size. And Mars is great and everything, but you don't want to end up like that. So the size of the planet is important, but so is the size of its star. If you're old enough to have had any schooling in the 20th century, you probably were taught that the sun is a typical star. False. The sun is actually larger than 90% of all other known stars, and most stars are red dwarfs, which are about 1/10 the size of the sun. To get a sense of what most of our stellar neighbors look like, look no further than Proxima Centauri. It's the closest star to Earth, other than the sun, only 4.2 light years away, and it's still too small to be seen with the naked eye. To stay warm around a star like that, you'd have to be orbiting very close to it. And in addition to putting you at greater risk from nasty surprises like solar flares and X-ray bursts, being that close to your star makes it way more likely that you'd end up tidally locked. A tidally locked planet is one that has one side always facing the star and one side always facing away. And of course, it's not just planets that do this. The moon is tidally locked with Earth. That's why you only ever see one side of it. Tidal locking occurs when a planet orbits too close to its star, and the star's gravity pulls harder on the near side of the planet than the far side. Over time, this effect drags on the planet's spin, fixing one side toward the star. And just imagine what would happen to a planet like Earth if it became tidally locked. Water on the side facing the star would boil away, and the water on the cold side would freeze. In terms of habitability, on the hot side, everything would be cooked, and on the cold side, not only would everything freeze, but there'd be no light energy to allow for things like photosynthesis. There'd be other unpleasant effects too, like the entire atmosphere turning into one giant, never-ending storm. On the far side of the planet would get so cold that the air would actually condense and fall to the ground, creating a vacuum in the atmosphere, and hot air expands, so the cooked air from the hot side would flood in to fill that vacuum. The result would be like living in the biggest, hottest, fiercest hurricane ever. And the odds of anything surviving that would be pretty bad. But it's not just the size of the star that matters, it's how old it is as well. The sun is what astronomers call a population 1 star, a relatively young star that formed along with its planets from a cloud of space dust that